Hi everyone. In this video, we will discuss about dynamic programming algorithm. It is used for optimizing the problem in linear time. Here, we needs to know first what is optimization. Suppose take a path from a source to destination. Here, we have different routes from source to destination. That is path 1, path 2, path 3, path 4, path 5. For given problem, all these are solutions. For example, let's think this is as a problem. Then all these the paths are, we can say, solutions. There can be many solutions from a single problem. Now suppose the condition is the time should be take less than the 45 minutes. There is some condition, the time should take less than 45 minutes. For example, this is taking 30 minutes, this path is taking 40 minutes, this path is taking 42 minutes, this path is taking 50 minutes, this path is taking 52 minutes. Then the feasible solutions are how many? It is 1, 2, 3. Only 3 feasible solutions are there. So among all the solutions, only few feasible solutions we can have. Now suppose what is meant by uh, optimal solution. That is here, for example, the condition is uh, we should take the less cost. That is actually optimal solution says like max or minimum. So this is called a optimal solution. For example, for 30 minutes it's charging uh, 20 rupees. For 40 minutes it's charging 10 rupees. 42 minutes it's charging 9 rupees. So the less cost here we have is 9 rupees. So 9 rupees, it is the optimal solution for given problem. So we can say there can be many solutions, there can be a few feasible solutions, but there is only one optimal solution. Usually for these problems we can use dynamic programming, or we can use a greedy algorithm to solve such these optimization problem. In this video we will discuss about dynamic programming. Just like divide and conquer approach, we have discussed like there will be one main problem, it can be divided into sub problem, sub problem 1, sub problem 2, sub problem 3, that we discuss in divide and conquer algorithm. But here there we discuss its non overlapping solutions, but here we will discuss the sub problem solutions of overlapping sub problem solutions. That is, we will first solve the simple base solution sub problem 1. Then using sub problem 1 we will solve sub problem 2. Then we will solve sub problem 3 and so on. That's we can solve the bigger problem. So it's like the main problem we are divided into sub problem 1, and using sub problem 1 we'll discuss solves 2, and with the 2 we will solve the bigger sub problem. So actually, understanding dynamic programming algorithm is solving a dynamic programming problem itself. So let's take an example. let's solve an problem, Fibonacci series. So first here, what is a Fibonacci series? A Fibonacci number is just a sum of previous is two numbers, but the base condition will be fib of 0 we will take as 0, fib of 1 we will take as 1, fib of 2 we will take as the previous one, fib of 1 plus fib of 0. So 1 plus 0 1, fib of 3 we will take as the previous sum 2, fib of 2 plus fib of 1. Fib of 2 we got 1 plus 1, that is 2. So Fibonacci series we will get like this. So in general we can say fib of I is equal to fib of I minus 1 plus fib of I minus 2. So let's write the program for this. In dynamic programming, we will have two approaches, bottom to top approach, top to bottom approach. First we will discuss bottom to top approach. So uh, uh, I will write the code directly, like how I will like take means I will take fib of 0 equals to 0, fib of 1 equals to 1. Then I will take the for loop, that is I equals to 2 to I is less than length, and I plus plus. I will simply take fib of I is equal to fib of I minus 1 plus fib of I minus 2. That is, that means what you're doing, we will first solve fib of 0, fib of 1, then fib of 2. So using fib of 2 we will solve fib of 3, then fib of 4, whatever up to the number. That means we are solving the sub problems using first sub problem 1, the base condition we're going for 2 and 3, that is 4, and so on n. We are solving the big problem. Let's see that in the code. So I'm taking here the code for it. First uh, let me take here function, that is a public static int fab. We'll pass that int n, whatever that we wants. Then uh, uh, first we will take uh, array to store, that is equals to new int n plus 1. Then fib of 0 is equal to 0, fib of 1 is equal to 1, for int I equals to 2 is less than or equals to n plus plus fib of I is equal to fib of I minus 1 plus fib of I minus 2. So this is the bottom up approach, fib of n. Now I will print that. Let's take fib of 4. You can pause the video and check for the solutions. So fourth fib we will get 3, for 5 we'll get 5, like that. Now let's discuss top to bottom approach. In the top to bottom approach, we will do the big problem will break down to small problems. That is, suppose if I take fib of 4, then I will solve fib of 3, fib of 2, Then I will solve using recursively. Fib of 1, that is again here fib of 1, and fib of 0, here also fib of 1 and fib of 0. So the base conditions, when it satisfies the base condition, it will return 1. It return it return here to 0. 0 plus 1 1. So for fib of 1 it is 1, so it is 3. 1 plus 1 2. So here 1 0, 1 plus 1, 1 plus 0 1. So 2 plus 1, so fib of 4 will get 3. So we will solve using recursively. So that I will write here. I will take that function public static int fib. I will take int n. Then I will take if the base condition asks if n is less than or equals to 1, then I will simply return that n. Now I will return simply the fib of n minus 1 and place fib of n minus 2. So I will get that fib of suppose 4. So fib of 4, uh, as you solved already, fib of 4 we are getting 3. The same thing we got here. So here, if I take fib of 5, I will get 5 like this. Now we will discuss one thing in top down approach. Listen, uh, just see here, for example fib of 0, I have calculated it as for one time, here two time. For example fib of 1, this is one time, two time, three time. Just the same function. For example, if you take fib of 2, here already we have calculated, but again I'm again calculating the fib of 2. So for the repeating say sub overlapping problems, we will just take that entire fib in array, and whenever if you already solved one, if you encounter, we will just take from that resultant array. That is this process is called uh, memoization. So we will talk about now memoization now. So what I will take here is, I will simply take here I will simply take here as first I will take some resultant array, that whatever that size n plus 1. I will fill everything as minus 1. For example, I want to find fib of 4. I will take size 5 0 1 2 3 4. The size is 5. So now I will whatever that common things, that 4 3 uh 2 2 1 0, that is 2 again, we will get 1 0. Whatever when there's a repeating, we will simply take that as in resultant array. So I will code the logic this. Now we will discuss the code for memoization. Let me take main method works. So I will take here first as a static int I'll create one, array to store that. Then static int, I will take that resultant array here. It is a new int of n plus 1. No, I will take a method public static int fib of, I'll pass int n. So if resultant of n, whatever I'm passing, it is equals to minus 1, then for that first I will make the result everything as minus 1. I'll make the elements everything in that array as I'll take up to size space. It is- and that res of I is equal to minus 1. Now I will print this suppose fib of 5. So Fibonacci series, the order flow like this. First is 0, then 1 for then 0 1 2, 0 plus 1 1, 1 plus 1 2, then 1 plus 2 3, 3 plus 5, 2 plus 3 5, 3 plus 5 8. Like this is follow the Fibonacci series. Then here, so first I will make everything as minus 1. Now if it something is minus 1, then I will take the code here. If n is less than or equals to 1 means I will simply return that res of n as n. Suppose it is 1, I'm taking it as it gives 1. If it is 0, it is it represent 0. Else I will take res of that n value as is equal to fib of, I will call recursive calls n minus 1. Usually it takes time to understand this code, so pause the video and check the logic. Minus 2, then at the end uh, I will return res of n. So it's all about the code now. 5. So our basic idea is when I equals to 5, it goes to here, it is 5. Then we will check res of 5, it is not there, so it not stored in the array, the 5. So it will go go and res of then the else part will run res of 5 equals to fib of 4 plus 3. For fib of 4 again will go. So then if 3 plus 2, 2 plus 1, 1 0 1 0, it will give, it will return to these previous functions. Then after if you already solve fib of 1, when you encounter again to solve fib of 1 means there the res of that particular thing already will be stored some value right here. It won't be minus 1, it will be already some value. For example, fib of 1 already 1 will be 1 will already stored. Then it won't work all these functions. The if case will fail, they directly return res of, that is res is an array we have stored. So that like this is a very important technique, memoization. So this uh, memoization is very useful for making reducing time complexity to increase here. There is an increase in space complexity, but there is a decrease in time compression. Although the space complexity increase, there is no much a problem, because if you check the browser should refresh in very few seconds, right? So the time only, it's a very important, space we can manage. So this is all about the dynamic programming. So you can pause the video and check the codes.